Good day. In this video, we will be discussing the answers to worksheet 11. Alright, let's get started with the first question. Now, A, B, and C are positive real numbers. Region E is a solid in the first octant under the plane x over A plus y over B plus z over C equals 1. And the job is to convert the volume of E into a single iterated double integral. And then part B is to calculate the volume of E. Alright, now x over A plus y over B plus z over C equals 1 is a plane. And so if you work out where the plane cuts the x-axis, that is A. If you work out where the plane cuts the y-axis, that is B. And if you work out where the plane cuts the z-axis, that is C. And so on the screen, you can see that if you want the points below the plane, it forms a tetrahedron. All right. So we want to convert the volume of the tetrahedron into a single, that means one, iterated double integral. All right. So the first task is to say, all right, if we look at the shadow of the solid on the xy plane, what does it look like? So let's start off by working out the shadow. Now, it's easy to draw it. If we draw it in the xy plane, then we have that it cuts the x-axis at A and it cuts the y-axis at B. And so let's call this region D, which is a subset of R2. So that is the shadow of the solid in the xy plane. All right. Now, let's be a little bit more specific. The coordinates of this point is A0, and the coordinates of this point is 0B. And so we want to be able to describe this region D. So we obviously need the equation of this line segment. All right. Now, I'm going to leave it for you. If you work out the equation of the line, you will see that the equation of the line is y is equal to minus b over a x plus b. So that is an easy high school problem to see that the equation of that line is y is minus b over ax plus b. All right. Now, the equation of the plane is x over a plus y over b plus z over c equals 1. And if you rearrange it, you get that z. So if you make z the subject of the formula, you get that z is equal to c minus cx over a minus cy over b. Again, I'm going to leave that algebra for you to verify. And so what we're going to do is we form the following function of two variables, hence the word let. Let the function of two variables be the following: c minus cx over a minus cy over b. So plane is z is equal to this function of two variables. So if you look at the way the question was phrased, we didn't have a function of two variables. So we created a function of two variables. So the function of two variables is c minus cx over a minus cy over b. And now we're in business, because now we can say the volume of tetrahedron E is written as a double integral over the shadow in the xy plane, the function of two variables dA. So f is the height above the xy plane. And so the question says it must be an iterated double integral. So you can now pick an order. You can pick dy dx or dx dy. I'm just doing one order, but you're welcome to do the other order. So I'm going to say, okay, the function is c minus cx over a minus cy over b. And I'm picking the order dy dx. So it means that I am shooting bullets vertically. So if I shoot bullets vertically, where does x start? The smallest x value is 0. Where does x end? It ends at A. So I'm shooting bullets vertically. And if I shoot bullets vertically, where does y start? Y start on the x-axis, which is 0. And where does y end? y end, where it ends on this line segment, given by the equation y is equal to minus b over ax plus b. And that is our upper bound, so minus b over ax plus b. And that, ladies and gentlemen, is the answer to part A. And now part B is do this double integral and see what is the volume of a tetrahedron that cuts the x-axis at A, the y-axis at B, and the z-axis at C. All right, so this calculation is not very exciting, but let's do the maths. All right, remember, we work our way from the inside to the outside. All right, so the volume of E is an integral from 0 to A. And now we integrate with respect to y. So this is cy minus cxy over A minus cy squared over 2b. The bottom bound is 0. The top bound is minus b over ax plus b dx. All right. And so then what you do is the integral from 0 to A, and you replace all of the y values with minus b over ax plus b minus cx over a, then you replace y with minus b over ax plus b minus c over 2b, and you replace the y with minus b over ax plus b squared. Closing, that's that term, that term, that term. Closing it, and then you replace y with 0, which is 0 dx. And then, ladies and gentlemen, simplify it as much as you can. So simplify it. Again, this is just algebra, so please do this. All right, and if you simplify it, you get it as the integral from 0 to A, and what survives is a half bc minus bcx over A plus bc over 2a squared x squared dx. All right, now I'm going to be smart. All right, it's good to be smart. So I'm going to take out a common factor of bc over 2. So I left with the integral from 0 to A. If I take out bc over 2, I left with 1 minus. If I take out bc over 2, I left with 2x over A. If I take out bc over 2, I left with x squared over a squared dx. Alrighty, and now let's integrate. We enjoy integration. So integrating 1, that becomes x. Integrating 2x, that becomes x squared over a. And then if you integrate x squared, it becomes x cubed over 3a squared. The bottom bound is 0, the top bound is a. Alrighty, and so if you plug in 0, we get 0, so I'm not going to write that down. And if I plug in a, I get a minus a squared over a plus a cubed over 3a squared. A minus a squared over a, that becomes 0. And so if I do the maths, this becomes bc over 2 times a over 3. And if we simplify that, we get it as abc over 6 as desired. And that, ladies and gentlemen, is the volume of a tetrahedron in the first octant that cuts the x-axis at A, the y-axis at B, and the z-axis at C. All right? A nice little problem. All right, let's move on to question 2. So question 2 states the following. Let E be the region in the first octant. So x is positive, y is positive, z is positive. Remind yourself what it means to be in the first octant. Between the following surfaces. So you have the surface x squared plus y squared plus z equal to 6. And you also have the surface x squared plus y squared minus z squared equal to 0. And we want to express the volume of region E as an iterated integral. do not evaluate the integral. So we just have to express the volume as an iterated integral. So this is the task, right? So you need to say what double iterated integral will you evaluate to work out the volume, all right? Now I'm going to do this with headings, and it's nice to have headings because it helps the marker to see what you're doing. So let's see where the two surfaces intersect, all right? So we want, when I'm going to rewrite the first equation as z is equal to 6 minus x squared minus y squared, and this one, if we rewrite this, and z is equal to the square root of x squared plus y squared intersect. Note, z is greater or equal to 0 because we're in the first quadrant. So you can see this one is a cone and this one is a paraboloid. All right, chapter 1 work, you got to know your surfaces. All right, so we want to know when they intersect, and so we can see, so x squared plus y squared, that is equal to z squared from the second equation. And from the first equation, we see it's 6 minus z. So if they intersect, z squared must equal to 6 minus z. So that means that we're going to have that z squared plus z minus 6 equal to 0. Yes, you can use the quadratic formula, but I'm going to factorize this. So I get z plus 3, z minus 2 is equal to 0. So z is equal to 2 as z is positive. So we reject the possibility that z is minus 3. All right? So we can see that they intersect when z is equal to minus 3. All right. And now we can see if they intersect, then we have that x squared plus y squared is equal to 2 squared, which is 4. And remember, we are in the first quadrant. So let's make a little heading. Shadow of E in XY plane. So that's easy to draw. So we're drawing the circle x squared plus y squared equal to 4 in the XY plane, remembering that x is greater or equal to 0 and y is greater or equal to 0. So if we draw it, it is a circle of radius 2, centered at the origin. However, we only take the points in the first quadrant. All right? So this is the shadow of solid E if we could draw it. Great. And now we want to write down the volume. So the volume. And in chapter 5, we saw that the formula for the volume is the following. It's the integral over, let's call this region D, so a double integral over D of the top function minus the bottom function dA. And here you can clearly see that the top function is the paraboloid, and the paraboloid is 6 minus x squared minus y squared, and the bottom function is the cone. The bottom function is when z is equal to the square root of x squared plus y squared. Alrighty, and so we can say that the answer is that the volume of E is the double integral over region D of the top surface minus the bottom surface dA. However, we want to write this as an iterated integral. So again, you have two choices. You can shoot bullets vertically or you can shoot bullets horizontally. All right? But if you shoot bullets vertically, you can see that x is clearly between 0 and 2 because the smallest x value is 0. The largest x value is 2. And you can see if you shoot a bullet, it starts here on the x-axis. This is where it starts. So it starts when y is equal to 0, and it ends on the circle. And if you rearrange the equation of the circle, That is when y is equal to the square root of 4 minus x squared. So y start at 0 and y ends when it hits the circle square root of 4 minus x squared. And so we can say the iterated integral, the x value starts at 0, ends at 0. The y value starts at 0 and it ends at the square root of 4 minus x squared. You have the top surface minus the bottom surface, and we pick the order dy dx. Alright? This is just one answer. It's not the only answer. You also could have picked the order dx dy. Now, if you want to evaluate this double integral, yes, you can. Just use polar coordinates, and it's a little calculation, but this is doable to do. All right, let's move on to question 3. Question 3 is a nice question. So we have a region which is a triangle. All right, so let's draw this triangle. All right, you got to know over which region you want to do your double integral. So we have region D. So the one vertex is at the origin. The other vertex is at the point 1, 0. And then you also have the vertex at the point 1, 4. All right. And here you have your triangle. Because it's a triangle, you have 3 boundaries. All right. You have this boundary, which is obviously when y is equal to 0. You have this boundary when x is equal to 1. And then you have this boundary when y is equal to 4x. Maybe we're going to need it, or maybe we're not going to need it. All right. Now, f is a function of 2 variables, but it is of the form x to the power r times y for some unknown real number r. And your job is to find the value of r so that the average value of function f over this region D, which we just sketched, is 1 over 5. All right? So we need to find this value r to have the property that the average of f over region D is 1 over 5. So we're going to construct a function of the form x to the power of some number times y. All right. Now, to do this, we're going to first need the area. All right. Now, the area of region D, we don't need a double integral, but you're welcome to do a double integral. I'm just going to do high school maths, which is a half base times height. And the base is 1, the height is 4, so the area of the triangle is 2. All right. Now, we saw in chapter 5 that f average is 1 over the area of D, and then you do notice 2 is positive, and at the double integral over region D of f dA, and we want the average to be 1 over 5. All right. So remember, we just worked out that the area is 2, so we want, let me say that again, we want the double integral of f over region D to be 2 over 5. Now, you can see the region is a triangle, and the triangle is both of type 1 and of type 2. All right, so you can shoot bullets vertically or horizontally, but I'm going to convert this double integral into an iterated integral. And so I'm going to say, all right, it's an integral, and my order is going to be dy dx because I'm shooting bullets vertically. So you can see the smallest x value is 0 and the largest x value is 1. And then I'm going to start on the x-axis, that's when y is 0, and I'm going to end on the line y is equal to 4x. So the top bound's got to be 4x, and the function is x to the r y. And we want this to be 2 over 5. And now we continue. And now we just do the maths. We first integrate with respect to y. So the integral of r with respect to y becomes y squared over 2. The bottom bound is 0. The top bound is 4x. dx is 2 over 5. Don't forget the dx notation is very important in mathematics. And so if I plug in 0, I get 0. If I plug in 4x, I square it, so it becomes 16x squared divided by 2, and so it becomes 8x r times x squared dx, which is 2 over 5. And again, a little bit of high school mathematics, we can write this as 8 times x to the power r plus 2 dx, which we want to be 2 over 5. And now we integrate this, so we're going to add 1 to the exponent, and we divide by r plus 3, because r plus 2 plus 1 is r plus 3. Plug in 1, plug in 0, and we want it to be 2 over 5. Now, if I plug in, this is meant to be an x. Apologies for that. If I replace x with 0, I get 0, so I'm not going to write that down. So if I plug in 1, I end up getting 8 over r plus 3 is equal to 2 over 5. Alrighty, and so now we solve. So we get that 40 is equal to 8 times 5 is 40, is equal to 2 times r plus 3. So we see that r plus 3 must be 20. And the only way for it to happen is r is 17. And that, ladies and gentlemen, is the end of question 3. Quite easy, right? All right. Now, there was a little bonus question to this worksheet. So let's have a look at the bonus question. Now, the bonus question is a nice question because in the bonus question, here we have a function of 2 variables, and the function is the maximum of x and y squared. All right? So, for example, and it's good to play with questions. So, for example, if you look at f of 5, 2, that will be the maximum of 5 and 4. And between 5 and 4, which is larger? 5 wins. If you look at 7, 3, now it's the maximum of x is 7. So, the first argument is 7. Y is 3, so you square it becomes 9. So who wins between 7 and 9? 9 wins. All right? So what you have here is a function of 2 variables, which is the maximum of x and y squared. And you're going to integrate this function of 2 variables over a rectangle. All right? So let's quickly draw the region over which we integrate. So x-axis, y-axis. You can see x start at 0, ends at 2. Y start at 0 and end at 1. So you can see, it's a very simple region over which we integrate. All right? We integrate over a rectangle. This rectangle depicted in the diagram. All right. Now, the function is maybe not something you've seen. It is the function which is the maximum of x and y squared. All right? So what will be a good starting point? All right? So a good starting point would be to draw when they're equal. So draw when x equal to y squared. So let's start off by drawing when x equals y squared. All right. So it's clearly a parabola, but x is a parabola in terms of y. All right. Now, if you draw it, it looks like this blue curve. All right. This is the point. You can see if y is 1, x is 1. So this blue curve over here, this is the curve y is equal to x squared. Alrighty. Now, if you take a point over here, for example, so let's take this point over here, which is the point 2, 0. Alright. You can see that the x value was 2, but the y value is 0 squared, which is 0. And you can see that the x, sorry, let me repeat what I was saying. So if you take this point, for example, or maybe we can take this point. This is the point 2, 1. So you can see x is 2 and y is 1. So you see y squared is 1 squared, which is 1, which is less than 2. So you see at this point, who wins? Y squared wins. X wins. At this point, who wins? Again, x squared wins. All right. If you take this point, who wins? X squared wins. Take this point, who wins? X squared wins. So everywhere in the green region, x squared wins. All right. So if you take a point in the green region and you ask yourself, who is more? All right. Is it x or y squared? And you see that x wins in the green region. All right. So between x and y squared in the green region, x is more. All right. Now, if you take a point over here, maybe you take the point when x is 0 and y is 1. So if x is 0 and y is 1, then y squared equals 1 and y squared is more than x. So in the green region, y squared wins. Alright? But in the green region, x wins. Alright? And on the blue line, nobody wins because it's a draw and they are equal. Alright? So what I'm trying to say, in the red region, y squared is more than x. In the green region, x is more than y squared. But on the blue line, you have that y is equal to x squared. Alright? And so this is good news, because now we can see, to solve this question, we got to divide the rectangle into two parts. This is part D1 and this is part D2. Alright? So we can say that the double integral of the function f over region D, dA, is a double integral over D1 of f dA plus a double integral of f over region D2. Alright? But in region D1, who is more between x and y squared? Between x and y squared, who is more? Y squared wins. And on region D2, who is more? X or y squared? X is more. Alright? And now we prefer having double integrals as iterated integrals because it makes our lives easy to evaluate them. Alright? Now for both of them, I'm going to shoot vertical bullets. Now, if I look at region D1, if I shoot a vertical bullet, you can see the smallest x value is 0 and the largest x value is 1. And you can see, where does y start? Y start on the blue line. Alright? And so if I shoot vertical bullets, you can see, where does y start? Y start on the blue line. Alright? So if it starts on the blue line, then you can see y start at x squared. And where does y end? Y end when it's equal to 1. So the double integral over D1 is an integral from 0 to 1, x squared to 1, y squared dy dx. Alright. Now, let's do the double integral over D2 as an iterated integral. Alright. Now, you can see, if I shoot vertical bullets, I'll have to split up the region from 0 to 1 and then from 1 to 2. So, to tackle region D2, which is this green region depicted above, so what I'm rather going to do is I'm going to shoot horizontal bullets. So if I shoot horizontal bullets, I can see the smallest y value is 0 and the biggest y value is 1. So this will be an integral from 0 to 1. And I'm shooting vertical bullets, so the order will be dx dy. And so it starts over here and it ends over here. So if you shoot a vertical bullet, so you can see, where does it start? It starts on the curve when x is equal to y squared. So where does x start? X start at y squared. And where does x end? It ends on this line, which is given by x is equal to 2. So it's a double integral from 0 to 1, integral from y squared to 2 of x dx dy. Alright, so here I've treated D1 using vertical bullets and D2 as horizontal bullets, hence they have different order of integration. Alright, I'm going to leave it for you to do the calculation over region D1. I got this as 1 over 5, so please verify that. Then I did the double integral over region D2. I did the calculation and I got this as 19 over 10. Alright, and then it's easy, 1 over 5, that's 2 over 10, 19 over 10. And to add up those two fractions, we get 21 over 10, and that is the answer to the bonus question. If you got that, well done, pat yourself on the back. Alright, ladies and gentlemen, this is the end of the solution or discussion of worksheet 11. I hope you enjoyed these explanations. Have a lovely day. Good day.